Howdy everyone. It's been too long since I've made any kind of meaningful video and life got in the way for a while, but I'm going to be back. So I figured I'd start making some videos again, and this will be the first one. I'm going to make some concentrating on diagnostics, and a lot of that's electrical. So I figured I'd walk through some of the things I use in electrical diagnostics and repair. Start with the obvious stuff: wire strippers, wire crimpers for butt splices and ring terminals, spade terminals, etc. Cable cutters, those are good for battery cables. I always have a marker with me. You never know when you're going to need to mark a circuit or mark a connector to tell yourself or remind yourself if you've checked it or not. And moving on, a couple different kinds of heat shrink tube. The standard non-glue filled and the what they call marine, which simply means it's coated on the inside with hot glue. So when you heat it up, it melts and seals it up. That I use for external connectors. The non-marine type, I'll use that for inside the cab, places that don't get any moisture, especially direct rain or anything like that. And of course, I do have a heat gun, but don't always have power to run it, so I bring a little butane torch with me. A couple different kinds of wire. I've got some stranded wire. That's mainly for just doing quick repairs to get a vehicle off the road or back to the shop. This is a solid core wire, which I find a lot more useful for making jumper wires and things like that. Jumping around a little bit. Scotch locks, which I don't particularly like, but they come in handy if you need to make an emergency repair. A couple of heavy cable lug ends, charge wire to the alternator would be one thing I could think of I'd use them on. These Wago type connectors, little lever lock ones, you stick the wire in, push the lever down to lock it. Those are good for quick repairs, as well as heat shrink and non-heat shrink butt splices and ring terminals, spade connectors, etc. This is something I always bring with me too. Retractable test leads come in very handy, especially in the diagnostics phase. You can run them right up to the battery. You got 30 feet of wire, so you can test things. Of course, electrical tape, and very important, liquid electrical tape. If I use a butt splice or anything, even if it's a heat shrink type, I put some of that on, because you can pierce through that outer jacket of those pretty easily with crimping pliers. Also, it's good for sealing up if you need to use a piercing probe on a wire. That is what you want to put over it so it doesn't get infiltrated with any liquid and damage the wire from the inside out. So that's pretty much it for the basic stuff. I will move on to some of the more advanced stuff here coming up. Alright, so I wouldn't necessarily call this stuff advanced, but it is necessary. You'll need a laptop or a cell phone and an adapter to be able to read codes. I also keep this little 80-watt power inverter with me. If I'm out on an extended ride in a car and the laptop battery starts to go dead, I can plug it in. This OBD adapter, the OBDLink EX, is what I use because I typically work mostly on Fords. And this one is optimized for use with Ford. And the laptop, I've got Forescan installed on it. It's just running in demo mode now. So that'll pull codes. You can do bidirectional control with it and control things like fuel pump, intake manifold runner control to do diagnostics. And that comes in handy. If you think you got a fuel pump circuit problem, you can command the pump on and start testing voltages. So there'll be more on that in the future. And let's go on to some other stuff. Alright, so moving on, we'll go into basic test equipment. Everyone should have a multimeter. They read volts, ohms. This one has a probe for temperature. And one of the handiest things you can get for it is these little alligator clips that go on the probes. Pretty much any electronics supplier, a lot of hobby shops will carry them. Next thing you need is a test light. It should be incandescent. You can get an LED one too, but you should have an incandescent test light. The reason is it puts a load on a circuit. This one draws about 1/4 of an amp, so an LED test light draws somewhere in the milliamps. If you've got a circuit with high resistance, like a bad connector in it or something, you could still light an LED test light with it. With incandescent that puts a load on it, you're probably not going to light the test light if the circuit's no good. This is basically just a multimeter. It's got an AC clamp on it. Sometimes I'll grab this one just so I can hang it off of something. And this is an AC and DC amp clamp that I hook up with. It can work with a multimeter, but I like using it better with my oscilloscope, and that will be coming up soon. Alright, let's have a look at a couple things that do pretty much one specific job. This is just a trigger switch to crank an engine over without using the key. You connect the two leads up, one to power and one to the signal post on the starter solenoid, squeeze the trigger and it should crank. That comes in handy diagnosing a no crank. You can tell pretty quick if the starter's bad or if you got a problem on the vehicle side. Next, this here plugs into the IPR valve on a 7.3 liter or 6 liter Power Stroke. You can take a resistance reading across it without standing on your head to get to it once it's plugged in, or you can simply connect it directly at 12 volts at the battery to test the IPR. You can energize the coil, and theoretically that should close the IPR valve. So if you've got a low ICP problem, you can crank it with 12 volts applied and see if it builds ICP then. And if it does, then you know you got a problem with the circuit or the solenoid or the valve itself. And last but not least in this category, it's just a cheap battery analyzer. Connect it up, set the cold cranking amps, let it run, and it'll give you a good idea whether your battery is toast or whether it's serviceable. This isn't a great unit, but it works. It gets the job done, and it wasn't only about 50 or 60 bucks, I think. Alright, now let's take a look at some more advanced test equipment. This and the next piece I'm going to show you in the next segment are the two last ones in this video. This is an oscilloscope. Some people may not know what an oscilloscope does, but to sum it up really quickly in a way that most people can understand, an oscilloscope it's just a voltmeter that takes a lot of readings very quickly and graphs them over time. That's all it is. If I apply voltage to this, I've got a 12 volt power supply hooked up. You can see it go up. And if I start taking the power on and off, it just graphs the power, how long it's on, and how high it went. It's that simple. But that tool comes in really handy diagnosing automotive. You can take readings off a bunch of different sensors like ABS wheel speed, crank position sensor, cam position sensor. Just the options are just almost unlimited as far as testing things. I won't go too deep into the operation of it here, but I will make another video covering basic oscilloscope operation and test methods. Just a few of the test leads I use with it. They have some alligator clips, and there's one that have a little grabby hook on the end you can hook onto a wire. Regular oscilloscope probe also. I don't use those a whole lot. Sometimes I'll use them if I have to do something higher frequency than normal, but don't use them very often. These also have a little wire hook on the end, or you can remove it and use it as a regular probe. Some other things that are useful. These here, they're set up as piercing probes. You can stick the wire in the little groove, and you can see the needle in there. You can pierce the insulation with it. I don't use the piercing a whole lot. What I use them for more often than anything is for back probing. they've got a steel pin. You can stick it in the back side of a connector and take a reading off the connector with it still plugged in. These leads, these have a banana plug on one end and an alligator clip on the other. Comes in handy. These have a banana plug on one end. You can stick that banana or that alligator clip right on the end of the lead. Whole bunch more back probe pins, and this is just a relay. It's just a simple 12-volt relay. But what I use it for is if you connect a scope probe to the coil, you can actually use it to get a signal off of a coil over plug ignition coil, and it works fairly well. You can get a pretty good idea what's going on with that cylinder. But that's a brief overview of the scope, and let's move on. The next one I think you'll like. It's like a power probe, but it's not a power probe. It wasn't expensive, and I've used it a lot. So let's move on to that. Alright, so this one is a really good value for the money. This is made by HWAUT. It's Hongwave Automotive, I guess, and it's a model P200. I learned about this thing from the Gadgets Playlist is the name of the channel. I don't remember the gentleman's name, but he did a quick review on it, and you know, it was obvious to me that I needed one. So I ordered one off AliExpress. It was delivered in a couple weeks, and I've used it a whole bunch since. It does a whole bunch of different things. This works as a multimeter, an oscilloscope, a PWM generator, and it just does so much. You can use it as a test light. It will actually load a circuit down, which is something that even the power probe doesn't do, or at least not the last model that I used. It comes in handy. Let me fire it up and just do a really quick demo of it, because I'm going to cover this tool in depth in a video in the near future. Alright, so real quick before I get started, when I took it out of the box, I knew there were a couple things I wanted to change. It comes with the alligator clips for the battery. All I did was add a polarized connector and make it so I could just attach a cigarette lighter plug to it in case I want to use it inside a vehicle. It'll be a lot more handy than having to drape the wire out the window and under the hood to the battery. The other thing I did right away pretty much was I just put some shrink tube over the probe. It comes as bare metal, and I can't see myself ever needing to test anything to the side of the probe. So I figured it would be a better idea to insulate it and protect myself against any screw-ups. So let's power it up. I've got a 12-volt supply here. Alright, so it's running. The wire coming off it here, that's another modification I'm going to make. I will probably cut this off here and put a banana plug in it just so that wire doesn't have to be there all the time, because it's constant ground. It comes in handy if you need to ground something, but I don't need it all the time, so I may as well make it removable. It does have a couple little LEDs to illuminate the tip of the probe while you're working, and it has a bunch of different functions. Let's see if we can get a decent picture. I'll scroll through them real quick. Voltage, resistance, diode and continuity. Lamp and load test, that's the one I mentioned before, where it acts like a test light. You can select, I think, 5, 10, or 30 watts to load a circuit with, and it'll run a quick test, and it'll tell you whether the circuit will handle the current or not. Oscilloscope, it actually does have a halfway decent oscilloscope built in. It's not great, but if you're under a vehicle and you've got this out and you want to just check and see if you're getting a signal from something, it works fine for that. Pulse width modulated drive. You can send a 12-volt pulse width modulated signal out. The one thing I wish they did was give you the option to change the voltage to like 5 volts, because not everything sees a pulse width modulated signal at 12 volts. If you wanted to simulate a sensor signal to the PCM, you probably don't want 12 volts unless it's like an active ABS wheel speed sensor or something. Battery resistance. It'll test your battery. Capacitor. It'll analyze a capacitor and tell you roughly the capacitance of it. It's not too far off. It's not perfect, but it's not too far off. Oh, battery startup drops too. You can connect this to your battery, crank the engine, and it'll tell you if it passes that test or not. I don't know how accurate it is, but it seems like it does okay. And that's it for that. So under DC voltage, let's just take a look real quick here. I'm going to demo this on the 12 volt. Oh, gotta set it first. There. $11.97, and the red light lights up. It tells you you're on a positive. If I go to the negative, it won't give me a voltage, but it will light up green and tell me I'm on a ground. You can also, with this switch, you can send positive or negative to the probe tip. That's something you don't want to be messing around with unless you're absolutely certain you can apply voltage or ground without blowing anything up. You can take out components in an electronic module pretty easy. So it's one of those things that before you hit the button, check it. If you're 99.9% sure that you can do it, check it again and make sure. But anyhow, that is a quick demo of this tool. And I'm going to make another video on it, an in-depth video sometime in the near future, and show some practical real-world usage for it. But anyhow, I think that just about does it for this video. Sure appreciate you watching, and hope you made it to the end. If you did, don't remember to like, comment, and subscribe. Thank you.